This screencast is going to be a review of the second order and zero order kinetics homework. So we began with first order, and then we kind of added on second and zero order. When we add those two in, there's this extra complicating factor of, well, how do I know what order is given when you're given time versus concentration data? So we'll kind of go through these. I'm not going to work each of these out, but I'm going to kind of talk about each one and give you the correct answers. That way you can check your own work, and then I hope that each of you will kind of work together if you know somebody got it right, and they can kind of help explain it. And then certainly mark anything that you don't understand, and we can come back to it when I get back to class. So on 29, I believe that's your first one, yes. So on 29, you've got NO2 and CO. They give you NO2 concentration versus time, and they want you to figure out the rate law, the integrated rate law, and the value of the rate constant. So you've been given this time versus concentration of NO2 data. So you have no idea of knowing if it's first, second, or zero order. So what you have to do, and you can either do this in Excel, or if you like using your graphing calculator, it'll do these types of things for you if you use your list, and then you can plot and find the linear regression, whatever you're more comfortable with. But there's really no way of getting around making graphs. And so I just kind of like to go in order. So concentration versus time, if that one gave you a straight line, it would be zero order. And then if we do the natural log of NO2 versus time and get a straight line, then it would be first order. And then 1 over the concentration of NO2, if I plot that, so basically you're finding these values and you're putting them in, right? And then you're doing, this is always going to be your X, and these 3 will be your 3 different Y's. So you had to graph those, see which one gives you a straight line. And remember that, you know, if you're back far enough on a graph that anything can look linear, so make sure that you're zoomed in enough that you actually see that it is indeed linear. All right, so 29 comes out to be second order. So the rate law, we would say rate equals 2.0 times 10 to the negative 4 times the concentration of NO2 squared. Now this K value came from the slope. So remember, we'll always say that the absolute value of slope is equal to the K. So this is the one that gives you the straight line. So you're taking the slope from this one. These slopes do not matter because they are not zero or first order. So that is your differential rate law. And your integrated would be 1 over the concentration of NO2 equals 2.0 times 10 to the negative 4 times T plus 2. And that comes from 1 over the initial concentration. So solving for what they wanted you to solve for in 29, that concentration of NO2 comes out to 0.14 molar. So that was your answer on that one. All right, moving on to 31. For this one, you've got a decomposition reaction, and they just straight out tell you that a plot of A versus time resulted in a straight line. So in 31, you don't have to do the graphs. They're telling you that concentration versus time gave you a straight line. So that tells you that it is zero order. They also gave you the slope was negative 4.0 times 10 to the negative 5th. And the absolute value of slope is going to be equal to your K. So for part A, the rate law, you would say the rate law is just equal to K. Because if it's zero order, your concentration is raised to the 0, and so it just goes away. So that would be your differential rate law. Your integrated rate law would be the concentration of C2H5OH equals negative 4.00 times 10 to the negative 5th T plus the initial concentration of C2H5OH. Part B, your half-life comes out to 150 seconds, or about 2.5 minutes. And part C, you get 313 seconds, which is 5.21 minutes. And that's using the half-life formula, T1 half equals A naught over 2K. All right, moving on. Sorry, this was 31, not 30. That was 31. All right, moving on to 33. We're back to them giving you time versus concentration data. They don't give you any clues as to what order it is, so you've got to go through and do all 3 graphs and figure out which one gives you a straight line. So when I graphed it, the one that gave me a straight line was a 1 over concentration. So when you did 1 over the concentration of C4H6 on the y and T on the x, it gave you a straight line. The slope from that graph was 1.42 times 10 to the negative 2. So that is the value of your K. So in this problem, they want you to solve for the y-intercept. Well, if you look at the integrated rate law, the y-intercept is equal to, so your y-intercept is equal to 1 over the concentration of C4H6. And that value from my graph, and again yours could be a little different, was 59.234. So solving for the initial concentration, I got 1.69 times 10 to the negative 2 molar. All right, on 35, this was the one that we talked about in the screencast itself. They've given you 3 graphs, and so you're just looking for the one that's a straight line. This is a classic FRQ question on the AP exam where they've done the graphs for you. They don't expect you to do a graph. And so the graph that gives you the straight line is the 1 over concentration versus time. And so that tells you that it is second order, so it follows the second order kinetics. So for 35, the y-intercept was about 10. So if I set that equal to 1 over concentration, I get a concentration of A to be equal to 0.1 molar. So 0.1 molar was your answer there. Alrighty, on 42, they give you the rate law. They also give you the differential rate law. So notice they said rate equals K times the concentration of NOBR squared. So that tells you that it is second order, which certainly simplifies it because you're not making your own graph. So in 42, it's a second order reaction, which means it follows second order kinetics, 1 over the concentration. So in part A, they want you to solve for the K. They've given you the half-life, and so we use T1 half is equal to 1 over K times A naught. So in that one, K comes out to 0.556 liters per mole per second. In part B, they're asking you to solve for time. So again, it's second order, so find that second order integrated rate law. Solve for T, and your T comes out to 16 seconds on that one. All right, let's see. Does that wrap up? Yes, so that wraps up your 0 and second order kinetics homework. Check your work, see if you can figure out where you went wrong, if you did go wrong, and help your classmates if they need help.